Today we will discuss about the process control subjects, which we will discuss about the ratio control systems. So what is the ratio control system we should know and where it is used. So ratio control is a process control strategies that is used to mix two variable and then maintain them at a constant level. Suppose that this is the two variables. Suppose that one variable is A, suppose that one variable A and another variable B. We want to maintain this A and B at a particular level. So such type of controller we can use this process control, the ratio control strategies. So when two or more variables must be maintain a specific proportions or ratio, that time we can use the ratio control strategy. It is commonly used in blending, mixing. If we want to maintain the ratio of two reactants at particular levels, so that can use to blending, mixing, when maintaining a right ratio proportion to the main stream and secondary. There are two types of stream we will discuss here. So we can say that this is the ratio controller. This is the, we can say we find the secondary flow. What is the secondary flow? So first we multiply primary flow into ratio. The ratio decided by the ratio controller. So this is the diagram of how the ratio controller can mix that two reactants in particular level. Suppose that this is the disturbance. Any process is going on and that process one disturbance will occur. So this is so we have to measure that disturbance because this is the continuous disturbance coming in the process control industry. So we have to maintain the output at desired level. So we can measure this disturbance. And second, this is the manipulated variable. This is the manipulated variable. This variable, if we want this variable at particular set point or level, so that our process will not be affected. So this line is called it manipulated variable. What manipulated variable? Whatever we want to give into the controller in process industry, so that the output of the process systems, industry process will not be changes because of disturbance. So suppose that this is the disturbance is D, and so we measure first disturbance using the flow transmitter. This is the FT is a flow transmitter. This is the FT is a flow transmitter. We measure the disturbance using the flow transmitter. We measure the flow transmitter is output is a DM. This is the flow transmitter output. This is the DM. This is the output of disturbance. Then we also, which is the manipulated variable, which is the going on, we can measure also. This is the using another flow transmitter. This is the another flow. FT is nothing but flow transmitter. We can measure the flow transmitter. Its output is a UM. And we can use one divider that, so that we can divide them. So we can divide this RM. How will write this? RM is nothing but U is a manipulated output. U is a manipulated output divided by a disturbance output. RM is a disturbance output. This is the RM. So this RM value we should provide the ratio controller. What is this value? We should provide the ratio controller, and another set point is given to the ratio controller, which is the another ratio. So this is called set point. Based on this set point, so that controller will generate the output P. This is using the RM and RD. That control using the RM and RD, that controller will then generate the output. This is the controller output P that generate the output P, and this output is given to another control valve. This whole function is called it control valves. This is called it control valve. So this is given to the control valve. Based on the output P, this control valve will open or closed. If the control valve is opening, then more manipulated variable flow through this streamline. If the valve is closing, if the valve is closing, so less manipulated variables, like when it may be steam, it may another things can flow through this process line. So this is the main working of the ratio controller. How will it work? First it measure the disturbance here, then it measure the manipulated variable using the flow transmitters. First disturbance measured value is using the flow transmitter is dm, and another flow transmitter using the manipulated value um, and we can take one divider and we take the one ratio and given to ratio controller, and another set point, so which we will compare using the ratio controller and generate the output P. Based on this output, the control valve reaction will open. So then the output will be transmitted to the ratio controller. This is the output. This RM is output. This we are talking output will transmitted into the ratio controller. And the ratio controller would compare calculated to desired ratio. So ratio controller will compare this set point ratio in RM, RT and RM, and that's the n. Then manipulated variable adjusted, because based on that output P generated, based on that this control valve will open or closes. Based on this, the manipulated variable will adjust according to the PI controller will be desired as a ratio controller. Here generally we use the PI controller. This here we will use here the PI controller. We can use the generally here the PI controller. This is the PI controller. We can use the PI controller. We can use the PI controller. Would have a desired ratio. The method would be the factor. The primary flow transmitter. This is a wild. Wild is nothing but is uncontrolled. Wild is nothing but disturbance. Wild means here, this is the wild means here, this is the disturbance, which is the uncontrolled flow. The secondary value automatically adjusted. This is the secondary value manipulated. This is the output of manipulated, which is automatically adjusted at the fixed ratio to the because of primary. Primary is nothing but this is the uncontrolled, or is another name is called it primary flow. So main component we have used the flow transmitter. We have already discussed flow transmitter to measure the primary or disturbance. Sometimes it measures the secondary. Here primary means this is the here is a primary means disturbance. We can say that the disturbance, which is the output DM using the flow meter. Secondary is nothing but manipulated variables. Secondary is nothing but manipulated variable. This is the called it secondary here, manipulated variable. Control station is the or ratio controller is called it. That's the control stations. Multiply factor or divided factors. That's multiply or divider factor we have used for other, or sometimes it's called it divider or multiplier factor. So PID controller used in a secondary control loop to control this. So what we have measured up to here, using the ratio controller, how we can measure in the process and industry. So we know that this is our closed loop control system. Up to here we know this is we have studied about our control subject. This is the here one. This is our feedback system, feedback process system. Up to here this is called it feedback loop. This is the feedback control loop. Feedback loop. Generally most of the industry this loop is used. So how the ratio controller this? Suppose that one disturbance. Suppose that one disturbance is D here. This is the disturbance. This is the here. This is the called it disturbance. disturbance. This disturbance is measured using the sensor or transducer. Then it generates the output, and that output generate the output in another measured process variable. Suppose that is manipulated, is manipulated. Sometimes it's called a manipulated variable coming from here. This manipulated process, this process may be desired from the here, or this this is the control variable. Manipulated variable is here. So sometimes this is a manipulated variable which is coming from the another where. Sometimes it's given to the controller, sometimes it's coming from here, sometimes coming from here. It's coming from the here using this, and is given to manipulated variables. So sometimes it's coming from the here, and compare them. Take the ratio here. Suppose that this is the RM measure, this is suppose the DM. Suppose that here this is the DM, this is the disturbance of primary variable. This output, suppose that this is the DM, and this is the suppose that UM, and it gives the RM. Then it's RM provided to the ratio controller, and already one set point exists between the ratio controller, and compare that, and it's provide that output. This output is provided to the, it's called a set point output, and based on remaining process we have is done, and this set point compared to another feedback is output measurement, and error will generate here. This is the set point minus process variable. This is the called it process variable. The output, the control output giving through the feedback system. So this is the difference between the error and process control given to the controller. Based on this error, controller generate the output. Controller changes the output until error must be 0. Whenever it stops, error must be 0, and this error is controller given to the final control element, nothing but control valves. Here generally most final control element, it may be actuator or it may be control. This is the control valves. Two things only. So that based on this and given to process, and this process control. So generally main use of the process controller is to deciding the set point for a feedback control loop here. So this is the called it ratio control strategies. We have discussed about the ratio control strategies.